Hello everyone, welcome to my Your Programming Club. Today we will be solving another daily LeetCode problem, and the problem's name is Find Missing Observations. So you have observations of n plus m six-sided dice rolls, okay, and with each face numbered from 1 to 6, okay, in the dice. N of the n of the observations went missing, okay, and you only have observations of m rolls, okay. Out of n plus m, n observations went missing of this six-sided dice rolls, okay, and you are only left with m observations, okay. Fortunately, you also have calculated the average of n plus m rolls, okay. So for these n plus m six-sided dice rolls, you have also calculated the average, okay. You are given an integer array rolls, okay, which will be of length m, and the entries in this integer array will be denoting the roles, the faces that came on a particular roll, or the value of the ith observation, okay. Then you are also given two integers, mean and n, okay. The average and the n rolls, uh, or observations, n observations which went missing, okay, and return an array of length n containing the missing observations that average to the value of n plus m rolls, so that the average of the n plus m rolls is exactly equal to the given mean value, okay. And if there are multiple valid answers, then you can return any of them. If no such array exists, return an empty array, okay, saying that such a situation is not possible, okay. And the average value of a set of k numbers is the sum of the numbers divided by k, okay. So if you are not aware of what the average value is, then it's mentioned in the problem statement. So, and there is a further note that mean is an integer, so sum of n plus m rolls should be divisible by n plus m, okay. So let's see how we can solve this particular problem. Before thinking of an approach, it's advisable to have a look at the constraints, so that you do not end up implementing or thinking of an approach which will give you time limit exceeded error, okay. So let's see the constraints. So according to the constraints, the length of the roles array, which will be showing the m observations, will be of order 10 raised to power 5, and n will also be of order 10 raised to power 5, okay. And each entry in this roles array will be between 1 to 6 both inclusive, okay, showing the faces of the dice that came up on a particular roll. So these are the constraints. So let's think of an approach, okay. So see, the first approach that came to my mind after reading this statement is, uh, if any of the arrangement is a valid answer, provided that the mean remains exactly the same, and the face values or the entries are in between 1 to 6, so why not try to divide the face values equally, okay. So try to divide the face values in n missing observations equally. So by equally I mean that, see, initially you were having only m observations and n observations were lost, okay. And what you can do is, and you are also having this mean average value, Okay, so let's say the mean is x. Okay, and you will be able to basically find the sum of n plus n observations. Okay, or sum of observations. It will be nothing but mean into n plus m. Okay, so once you are having the sum, then what you will do is, and you are already having the m observations that are uh, there with you. Okay, so you will subtract the values of m observations one by one from this particular variable, you can say sum of observations. Okay, so once you subtract all the values of m observations, then you will be this will be converted into sum of n observations. Okay, now you are having the sum of n observations, and you decided to divide the face values in these observations equally as possible. Okay, so what you will be doing is, you will be dividing this whole thing by n. Okay, once you divide it, then you will be having uh, as equal as value as you can get, so in terms of the quotient. Okay, and let's say it comes out to be y. Okay, then if there are, let's say the situation was like this, the sum of observations was 5, and the number of observations, let's say it was, what should we take, uh, let's say we take 3. Okay, n is equal to 3, and this sum is equal to 5. Okay, so if you divide it, then it comes out to be 1. Okay, so this comes out to be 1, and so you know that at least if you are going to divide 5 things into 3 of them, then you should be giving 1 to all of them. Okay, so 1 is given. Now there might be some remaining values which will not be able to distribute equally into these 3 or n observations. So for that, what we will be doing is, we will be taking modulo of 5 with respect to 3. Okay, 5 modulo 3. So it will give us the remainder, which is 2. Okay, now for the any two entries you want, you will give them one extra. Okay, so let's say extra is denoted by green, so I decided to start from the very beginning and give them each of the two entries one extra. So the distribution comes out to be 2, 2 and 1. So like this, we can divide the face values as equally as possible into the n observations. Okay, so first of all, you will be doing a simple division and getting the value. Okay, integer value. Once you are having it, then you will be seeing what extra, how many entries will be getting extra values, and you will be giving them extra values of 1. Okay, so this is what you will be doing. So in you see the total remains 5. Okay, so this is how you can distribute the face values as equally as possible. Okay, so as equally as possible. So this will be the same logic that will be applied, and we will be taking care of some edge cases, and then we will be pretty much done with the implementation. So now let's see the implementation part, and let's take a fresh slide for that. So this is the implementation, and I hope it is visible to you. Let me, yeah, I think this should be visible enough. Okay, so what we are doing here is, and let's break it down a little further. Yeah. So as I told you, we should be having the roll sum, okay, or the sum of n plus m observations. Then once you have it, you will subtract the values of m observations or roll values of these m observations. Okay. So once you subtract that, then your roll sum will be converted to sum of n observations. Okay. And so if the sum is now negative, it means that you will not be able to do a valid distribution. Then in that case, you will be returning the empty array. Okay. And then if that's not the case, then you will proceed on for calculating the face value. Okay. We are trying to distribute the face values among n observations as equally as possible. So we are getting the initial face value that will be distributed. So roll sum, which is the sum of n observations divided by n. Okay. So once you are having that, then you will see are there some faces that will be getting some extra values of +1. Then you will take a modulo operation, do a modulo operation. Okay. And once you are having that value with you also, the faces, number of faces that will be getting the extra value, then you will do a check whether your face value was equal to 0, or the face value plus, if there are some extra faces getting some extra value, +1, or else 0. So see, the whole logic is that the face value should be within this range. Okay. So if it is not within this range, okay, taking into account this number of faces that will be getting extra value also, then you will be returning an empty array saying that it is not possible to have a valid arrangement. Okay. So this is what we are doing in this particular check. Okay. So this is the whole thing in okay, nutshell. And then you will be having an array which was required from this particular function that we have to complete, and it will be of size n, showing the n observations. Then you will give each of these n observations the face value, and if the number of faces that will be getting extra values are still greater than 0, then you will add 1 to the current face value. Okay. And then you will be simply returning your roles array. Okay. So this is how you will be solving this particular problem. And if we talk about the time complexity wise, as you may have seen that this was executed n plus, let me change the color here, this was executed m times. Okay. Size of this particular roles array, and this particular loop ran for n times. Okay. The size of the resulting array that you will be returning. Okay. So in total you can say we are doing a linear time complexity of order n plus m. Okay. M for subtracting the values one by one, okay, from the roles, roll sum, and then n for filling the array. Okay. Other than that, we are not using not doing any kind of traversal, so this will be the time complexity. And space complexity wise, if you consider the array that will be used for storing this particular result, then it is order of n, and if you are not considering it, then it's order of 1. Okay. So it's totally up to you. So these will be the complexities. If you are still having any kind of doubts or any queries in general, then you may ask them in the comment section. And I really hope this solution walkthrough added some value to your journey of honing your DSA skills, and keep solving more and more problems. And I will be seeing you in the next video. Thank you for watching.